A reversible reaction is a chemical reaction that results in an equilibrium mixture of reactants and products. For a reaction involving two reactants and two products, this can be expressed symbolically as A and B can react to form C and D, or, in the reverse reaction, C and D can react to form A and B. This is distinct from reversible process in thermodynamics. Weak acids and bases undertake reversible reactions. For example, carbonic acid, H2CO3 plus H2O, L, AaHCOA3 plus H3O plus, AC. The concentrations of reactants and products in an equilibrium mixture are determined by the analytical concentrations of the reagents and the equilibrium constant, K. The magnitude of the equilibrium constant depends on the Gibbs free energy change for the reaction. So, when the free energy change is large, then the equilibrium constant is large and the concentrations of the reactants at equilibrium are very small. Such a reaction is sometimes considered to be an irreversible reaction, although in reality small amounts of the reactants are still expected to be present in the reacting system. A truly irreversible chemical reaction is usually achieved when one of the products exits the reacting system, for example, as does carbon dioxide in the reaction, CaCO3 plus 2HCl CaCl2 plus H2O plus CO2a. History. The concept of a reversible reaction was introduced by Berthollet in 1803, after he had observed the formation of sodium carbonate crystals at the edge of a salt lake, 2NaCl plus CaCO3 and Na2CO3 plus CaCl2. He recognized this as the reverse of the familiar reaction, Na2CO3 plus CaCl2 or 2NaCl plus CaCO3. Until then, chemical reactions were thought to always proceed in one direction. Berthollet reasoned that the excess of salt in the lake helped push the reverse reaction towards the formation of sodium carbonate. In 1864, Warge and Guldberg formulated their law of mass action, which quantified Berthollet's observation. Between 1884 and 1888, Le Chatelier and Braun formulated Le Chatelier's principle, which extended the same idea to a more general statement on the effects of factors other than concentration in the position of the equilibrium. See also, dynamic equilibrium, chemical equilibrium, irreversibility, microscopic reversibility, static equilibrium. References